Hello, good afternoon, happy Tuesday. We are going to be playing some coding game today. So let's see. Yesterday we left off where we had we finished making our bot work in general. We need to slow down, and we're turning sort of like at the correct times, and we are attempting to get to. Oh, we need to slow down when we're hitting like a big turn into the current checkpoint. So that's kind of where we are right now. But what we need to figure out is how to get that angle. How to get that angle between us and the current pod. So if we take a look at our coding game. I guess this is from the last time we went through. We have an angle, like, okay, so for pod 1, this is pod 1. Our angle is 101, 101.0, 101. We're pointed nearly down. And now it says it like 90 is to the right. So if we're pointed like that, that's 35. This is back, okay, pointing straight up. That is 305. I'm curious how the angles are working because I'm not completely sure I understand. So I want to print out what the angles are. So that's where we're going to start. So right now we have, let's see, for a pod, maybe I want to like print the angle. So here's that angle. What if I just have like a pub function debug angle? And wait, do I? Oh, I have the angle here and it's public. Never mind. I don't need to do an entire debug for this. I probably want the main library. Okay, so in loop, we have the state, init turn. I don't want to debug the entire state. So for each turn here, I want to do a debug pod 1. Okay, so state pod 1 unwrap angle, and then I want you to be state pod 2. Okay, so we are orange. We see this angle going It's very interesting. I'm not really sure. Not really sure how to read this. It's like, okay, so starting from the beginning of the race, I'm aiming at up and left for both of them. And that is 233 and 223. And at some point, it like pod 2 aims a little bit higher up, which is 228. So that went down from 230. Okay. So it looks like closer to up, that's going down. But like, I would have thought that straight it would be 0. Is there ever a time that we are close to 0? Okay, here's a pod 2 and pod 1 are both like close to 90. Here, pod 1 is 90, pod 2 is 89. I can't even see the other pod, but this pod is pointed straight down. So 90 is straight down. The provided angle is absolute. Oh, that's what it is. Okay, so for some reason I misread that. 0 degrees means facing east. So 90 means facing south. So 0 is east. Interesting that they would choose that. And then rotating. Okay, so 90, so 0, 90, 180, 260. That's the way that it's pointed. How can I use that to find the angle? Like, okay, let's say we have point 1, we have point 2. So it's also, I guess, here's a pod. So we have our pod. We have a, what is it, the target? This is the checkpoint. And so if I'm facing straight up and I need to come here, this is the, I guess I have this line, so I can calculate this line because I know where the checkpoint is and I know where we are. I will be able to, I'll be able to figure out this angle right? Because if I just go straight up until it's at the same y, I can figure out what this is. Which means I have that. Okay, so I just basically need to create this point here, don't I? So this will be that point. I'm not sure if I can use the given angle in any way that's like really helpful. Okay, so let's say we have our pod location, we have the checkpoint location. Okay, so we know those. Now, this other one is just going to be the pod X plus the checkpoint Y. That's what this is. So that's like the third triangle. So I need to calculate angle. Where will this live? We have our pod, we have a point, and we have the state. The pod maybe needs to calculate the angle. Okay, so if I take a mute self, I guess we're gonna I'll add in like angle to next checkpoint. And I could start this off. I wonder if we don't have it. We might not have it right away. So I'll have to do an option. Okay, so and calculate the next angle to the checkpoint. So we have Skimus, hello. How are you doing today? You believe it starts facing out the checkpoint? Does it? You're probably right. That kind of looks like it's facing the checkpoint, doesn't it? So if it starts facing the checkpoint, then the angle would be 0, wouldn't it? So in that case, I don't have to make this an option. We'll just make that an F32, and then you can be 0. My brain keeps on wanting to write next checkpoint, and that's not what I mean. Because the rules state that it never rotates on a first tick. Oh, okay, so that's good. So we start at 0, so that's just an assumption of the game, right? So okay, we always start the race facing this first checkpoint. Now, calculate the angle to the checkpoint. We need to constantly do this. We are not going to return anything. We're going to update our angle. So what do we need to know? We need to have the checkpoints. Which is going to be the slice of points. And then we already know our next checkpoint ID, so we can get that one. Okay, so we get that, and then we want our current self. So we have our current position. So then I need that third position. What, I don't know what this is called. I assume that in geometry, this point that I'm going to create has like a name that we would call it, because we have like our position, the position we want to find the angle to, and then we have this like anchor point that we're going to create to allow us to like figure out what the angle is. So like anchor. And so that's going to be, oh, projection. Oh, okay. Thank you for that. Also, hello, Mumi. How are you doing today? So we're going to do a point, new. We need, it's going to be Rx. And then the checkpoint Y. Are you finding the angle with respect to orientation or velocity? I'm trying to find, ooh, you're right. That's a good point. I was just doing based upon position, but that's not correct, is it? I need to know based upon orientation, don't I? So if I was pointed like that direct, let's see, do I care about it? Do I care about the velocity or yeah, I don't know. What do I care about? Because if I'm, well, okay, so if I'm pointed this direction, as in I'm facing that direction, but I'm moving like this direction towards the checkpoint, I don't want to go. I don't want to like press the gas. So it's my orientation that I care about then. So this is what I need to calculate, something like this. So I'm given an angle according to east. So if my angle is like, let's not worry about these for a second. I wish I could rotate this, but I don't think I can. That'd be really nice though. We'll have to just pretend. So let's say I am pointing this direction. So you could always rotate the world around the pod to make it equivalent. That's true. That's true. I could always rotate the world. I don't know what that would give me though. So I have a rotation in like 0, 3. Oh, just for visualization. That's true. I don't know how to rotate this, like the canvas either though. So I don't know. I don't know how this would help. Oh, would you like this? Okay, well, apparently it's standard. That's 0 degrees. Hey, so this is going to help me. When I'm holding this, it gives me, I don't know if you can see it, the degrees. Okay, so that's perfect. Oh, but 90 is up there. I think 90 is down here, actually. So it's reversed. So let's start with the basic one. If we're 0 degrees, and my checkpoint is up here, so I'm pointing to the right, my checkpoint is here, I want to figure out based upon me pointing this direction, what is the angle to here? I would say in that case, you want to find the angle between orientation and velocity and damp your thrust when the angle is above some threshold. Well, I don't know if it's that simple. Maybe I don't think I actually care about or maybe I do care about the velocity then. Basically, I care about it probably is velocity. That's probably what I care about, is my velocity. So we have the angle of, so let's say this is the orientation. But let's say that we have another one, which is velocity. And let's imagine that you're something like this. I do care about that. This angle is probably more important than orientation. I need to... Oh, not velocity. I meant to say orientation and the checkpoint. Basically, you don't want to thrust away from the checkpoint. Yeah. Yes. And I want, like, if it's too big, I want to slow down so that I can hit at least the edge of the checkpoint when I go past it. So if I have my velocity, okay, so here my orientation would be 0. So the current orientation slash this would be provided angle. This is 0. Given that, how do I calculate this? I guess I need to create a point like this. So if I go all the way to the right to the edge of the arena, we know that this is, this position is the max X and the arena 0. But I can probably just choose an arbitrary number, can't I? If I choose an arbitrary number, as long as it's not, well, heck, even if it is technically outside of this, it's still going to calculate the angle because the angle is the same regardless of how long this line is. Unless I just do something weird like that. Here, there. And then that gives me the ability to figure out what this is. So if I take my angle and I just say, okay, I want to take 0, and add to this, does not help because that doesn't move it out here. That just keeps the point exactly the same. If my angle was this 90 degrees, so for 90 degrees, my X doesn't change at all, but my Y changes. The same with 180 as this one. It's just to the left instead of to the right. And I think where it gets interesting is something like this. So I need to calculate this angle rate, right? So not that one, but like wherever this is my facing. And what I'm given is a number in degrees of 0 through 360, with 0 being to the east, like this. But that's it. Like, it's just a number between 0 and 360. So I need to create a vector. So that way I could then create this pointing towards the end of that vector. That's what I need to do, is figure out how to create this anchor point. That way I could then calculate this angle here. Because if my angle is 0, you just Googled an angle between vectors and found a nice formula. I guess like the problem is I need to create a vector. I don't have 2 vectors yet. Because I have a position and a position, but that's not helpful. Just look up rotation matrix on Wikipedia. Okay, let's take a look at that. Wikipedia. Come on, DuckDuckGo. Oh. Okay, rotation matrix. In linear algebra rotation, a transformation matrix, the user perform a rotation in Euclidean space. Jim, hello. How are you doing today? Okay, for example, using the convention below the matrix. Okay, so it's a 4. What is it, like a even matrix or whatever? An equal matrix or weighted balanced matrix? Oh, it's a 2 by 2. Yeah, 2 by 2. Well, so what is this? Counterclockwise rotation of an angle. This rotates column vectors by means of, hold on. This type of stuff makes it, I'm very hard to read these. Can Rust U interact with other web pages on the same server? I like to have web browsers open that communicate with each other. There are a couple different ways to have websites communicate with each other. The classic way to do it would be to have them use the same server and then have like one web page communicate to a server that then sends that back to the other web page. That's probably like the safest way and the most reliable way. There are like WebRTC does allow you to communicate browser to browser directly. So technology like that does exist. I haven't used it though. So, I mean, there's no, like, it being you doesn't really change anything there. It's just more of like web limitations. So that's what I would either do like a WebSocket to a server and then have both them talk, and then it can just like send messages back and forth, or send WebRTC for back and forth like that. Something like tic-tac-toe or battleships. Yeah. So you probably, if it's a game type thing, you probably want a server to validate everything. Otherwise, one client can just claim it's cheating from the other client. Okay, so what was this? This was the second formula in the introduction itself. So this one. Okay, so to perform the rotation on a plane point with standard coordinates, so a vector of x and y, it should be written as a column vector and multiplied by the matrix R. What's R stand for? Like the amount that it's being rotated? Like the desired rotation? R is that 2x2 matrix. Okay, so R is the entire matrix. Oh, okay, I see. R is the matrix itself. And these would be the x and y coordinates? Or would these be the x and y coordinates? One way to understand this is, let's say we have a vector at an angle 30 degrees from the x-axis, and we wish to rotate that angle by a further 45 degrees. We simply need to compute the vector endpoint coordinates at 75 degrees. Yeah, so these are my vector. X and y are the coordinates. The other stuff is calculated from the desired angle theta. But I don't have the desired angle, right? I guess that's what I'm trying to calculate, is the desired angle. All right, well, thanks for stopping by, Jim. Have a great rest of your day. Yeah, then you plug in x and y and solve for theta. Okay. So let's see if we can do this by hand and figure this out. So the simple one first. Our rotation is our positioning. Our angle given to us is 0, right? So that would be 0 because we're facing this direction. And our checkpoint is up here and we're right here. So we're facing directly to the right. So let's not do terminal. Let's do nope. What is it? Notepad? No. Notepad is Windows. Text edit. Everybody does math in text edit, right? Let's put this over to the right, you over here. Okay, so we start with our pod position is going to be X is, let's say, like 50. Y is like, we're going to do something really, really simple to begin with. Our checkpoint position is X is like 100 is 0. So it's above us and to the right. No, so you have orientation angle. You start with 1, 0. Rotate it by orientation angle to get orientation vector. Then range, checkpoint, then angle between range and orientation is cosine h dot product range. Wait, so we have orientation angle. Correct, so we have the orientation angle. And that's 0 right now. So directly to the right. You start with 1, 0. What's the 1 come from? Like where, okay, so 0 would be the angle. So, okay, this X and Y is my pod's X and Y. So we would have what? What does this symbol mean? Like, I guess I don't understand what these numbers are supposed to be either. And that entire thing is multiplied. The orientation angle is measured with respect to the x-axis. So anything on the x-axis can be chosen. Oh, okay. So it doesn't matter where. We're just like setting it to be. Okay, so we're just starting it at 1 because of reasons. It could be literally anything. I could choose 100. I could choose 1,000. I can choose negative 100. But we're just starting with 1 because it just makes it easy with math. Okay, so measuring starting at like, I guess a random. Correct, yeah, negative will have angle 180 degrees. I probably need to keep that into account because what if it's behind me? Okay, so we're starting at 1, 0. So that would be x for 1. So we get a positive angle, ignoring y, so it's 0. Okay, so we're starting here with S1, 0. And that becomes this x and y here. What is this? Through angle theta? That's what my procedure is about. You start with 1, 0 and then use that Wikipedia formula to rotate it by the orientation angle to get the actual orientation vector on every tick. Okay. And then we use that to calculate the angle to the checkpoint. Okay, cool. So what is this? What is cosine theta? And where do I get this number to fill out the matrix? Is this like an x and y? Like my x, my y, their x, their y? Oh no, it's angle 0. So this can't be y. So through an angle, so do I know what that is then? Theta is the angle you're rotating by. Okay, so we don't know what this is. So this is our unknown that we're trying to calculate for. Oh, so this is the orientation angle. Okay, so this would be, okay, so we have our orientation angle 0 to begin with. So this is the first one, the first case where we're facing to the right. So this would be cosine of 0, negative sine of 0. Okay, so our first one would be 0, negative sine of 0, and we multiply that by x and y. And then that gives us x cosine of 0, and then so that becomes, so in this case it'd be x, so that'd be 1 times minus 0 times 1 times sine of 0 of well, isn't this like basically I'm thinking of, no, that's not gonna work. Of this, I'm plugging into the x that we have. So the x is 1, right? So this becomes 1 times whatever cosine of 0 is. Cosine of 0 is 1, so that becomes a 1. Minus 0. Okay, yeah. So I'm breaking out one part at a time, right? So plus y, that's 0 times that, essentially, is what we then get. And then that is obviously going to become 1 times 1 minus 0 times, and a sine of 0, is that also 1? Well, it doesn't really matter, right? Because 0, well, what's a sine of 0? Sine of 0 is 0. Okay, so 0. And then, so 1 times 0 plus 0 times 1. So that would be 1. So 0 times 1. We solve for both of those. And then that obviously becomes 1 minus 0. This would become, wait, how do I do a dot product for, this is now just like the top and the bottom of it, so it just becomes, oh, it just becomes x and y, right? So x, our x then is 1 times 1 minus 0 times 0, so 1 minus 0, so it's 1. I'm doing rotation by 0 degrees. Okay, so perfect. So, and then this is 1 times 0, 0 plus 0 times 1, so 0. Okay, perfect. So, and then I can, this is almost like a normalized vector, so then I can multiply it by 100 or something like that, or it doesn't matter. I just now create my extra point. If it's 0, I then say you're like just right here. And I just say you're like, you know, that you're 1, and you just like add the x by 1, add the y by 0, and then go from there. Okay, so that's in the case that it is exactly to the right. Now let's say it is not exactly to the right. So down would be, so this is sort of like a weird state, because over here is 90 degrees, but in the game 90 would be straight down. But for the math, I'm going to check myself with this way. So we're going to do 45-degree angle. So if I do 45 degrees, so orientation angle, $45. We still start measuring at 1. So we do that 1 times cosine of 45, sine of 45. So these become 45s in here. So this is going to be 1 times, and then let's bring up that calculator that has never ever pointed us wrong. So we have 45, that'll be the cosine of that. So that's what, 0.70. Let's see, that's also the same for this one here. And then we have sine of 45. Oh, is that the same? Ah, interesting. Okay. So then if I take these, so 1 times that is exactly the same thing. So this number becomes, oh, wait. So 1 times that is, I wonder if I could just take this. Oh, minus 0 times that. So it is literally this thing. So now you are that. No. Now you are that. And then 1 times that. So it's literally going to be the same thing here. So now I know x is slightly to the right and slightly up from me. Okay. Now I can multiply this by like 10 or 100 if I want the point to be a little bit farther away to like help do some math. But I don't think that matters, right? I don't need to. Okay, so the anchor point. To calculate our anchor point. Yeah, I don't really need to extend it unless you care about a specific point on the ground, which I don't. If I was targeting based upon that, I might, but in this race, I don't need that at all. I just need the angle. So we'll just leave it as this. So we're going to do, our x is going to be this. So let's do this once at a time, right? So like this is going to be an anchor. X is going to be equal to, so this is going to be 1. This is all happening. Okay, so that's going to be the cosine of the number. So that's going to be self that. So we have angle, and I want the cosine of that. Minus 0. Now that you understand math, you can go ahead and use a tan 2. Oh, this sounds really familiar. I've used a tan 2 way, way, way a long time in the past. A tan 2 is, okay. By definition, is the angle measure in radians between the positive x-axis and the ray from the origin to point xy in the Cartesian plane. The image is probably, yeah, so this image, okay, so if I give it the angle, I then also give it the y and then the x of my position. You give it y and x and it gives the angle back. I give it the 1 0. I give it the 1 0. Okay, so I give it the 1 0 and it gives me the angle back. Okay, I got it. So let what do you give back? You give back this like x and y. What are you going to give me? I'm really curious now. So I want self that angle, a tan 2, computes the 4-quadrant arctangent of self y and other x in radians. How does that work? It doesn't take two things. It takes one thing? I'm not sure this is helpful. Well, like self y. Yeah. Well, so I was calling it on this angle that I have, which would be like the 45 degrees, for example. So I know. A tan and not a tan 2? No, I don't think that's right either. Yeah, so the problem is a tan 2 only takes in one thing, and there needs to be an actual. I can't do it off of F32. I have to do it off of a specific number. So I was trying to do it based upon the angle, like which would be the theta that we were using here. So like I was trying to do it off of like the 45. Self is the y and you pass in the x. Okay, so that would be 0. That would be, no. I'm starting at 1, 0. Now I'm confused. I don't know, like if we're doing 1 and 0 all the time, I would do 0, and then it would never change, right? Like these are just static numbers that we always choose. This is the only thing that differs. So like where would I use this in it? Unless I take my current position and I add the angle to each one. So I do a vector addition with a scalar. And I add, like, let's say 15 to that. So if I'm at position 0, if I'm at position 50, 50, so that would become 65 for the x. And I don't know. Wait, does that even make sense? I guess it moves it up in that angle that way. So I don't know if that makes any sense. Or I stay on the x plane and I stay on the y plane exactly where I am. So I just add my x. No, that doesn't work either. Yeah, like vector and scalar addition is not a thing. Multiplication is a thing. I don't know how arctan 2 is going to work for this. Oh, sorry. Yeah, is it arctan 2? Yeah, arctan 2. Because I don't know what that first number is. Thank you, Skimus, for the help with this. Rust also has the inverse of a tan 2, which is right, but how is that going to help? Like I guess like I have trouble like visualizing this type of stuff. Like the numbers literally mean nothing to me, and I can't necessarily see it. I have a really hard time like turning this into like a visualization in my head. So a sine cosine angle returns an x and a y. A tan 2 xy returns an angle. But I don't see how that's going to help me. Because I don't have an angle. I have an angle, but I don't have an angle in relation to anything. I guess I have an angle in relation to where I'm pointing on the field. But not in relation to... I guess I have it in position to my position, right? Oh, so if I do sine cosine of the angle, that returns an x and a y, and I could then add that to my current position to get like another angle. Or to get like another point, and then I use that to calculate the angle, maybe. So that would be sine cosine of the angle. So if I do self sine cosine, then this is going to return angle x, angle y. Which then I can use to create a point. So this would be that our angle point. Well, I don't have a current vector. Oh, the current position to the checkpoint. I don't know if I need that right now. Like what I need to do, but Mero, hello, is so I need to calculate where this is, like some kind of anchor. So I already have like a line for this. I need to figure out this. Once I figure out this position, then I can figure out that, and then I can get this angle here. That's what I'm going for. The square represents a anchor, so like a basically if I'm facing like, let's say this direction. So I'm facing that direction, then this would be like just anchor or whatever. I need a third point in order to calculate the angle between my pod and the checkpoint and like my facing. So if I just randomly put this over here, that completes the triangle, and now I can calculate this. But I need an XY to figure out where this is. If you're only using it for calculating the angle, why not get the angle directly without an anchor? How do I get the angle? So if let's say I don't have this, all I have is I have a number, so a scalar of the angle that I'm facing. So let's say I'm facing at 0 degrees, which would be to the right, eastward. And then I have this as my vector. How do I know what my angle is there to the checkpoint? Unsupervision, hello. How are you doing today? Could be your angle relative to the x-axis. How would I, well, let's see. Yes, this angle that I'm given is relative to the right x-axis. So like facing completely east. Wait, so atan 2, vector x, vector y, but okay, what are the vectors? Is it my position here, or is it this position here? Or is it the difference between these two? Gives you angle between the x-axis and the checkpoint, and then you can just take the difference of your orientation and that angle. Okay, yeah. So the vector would be this line here essentially. So the vector would be like pointing from the pod to the checkpoint. Okay. So if I get that, so let's I have my checkpoint there and I have my position. So let's say let our distance is going to be the checkpoint minus self dot position. Okay, so that gives me my x and y point. And then we can do our angle. So take the difference between your orientation and that angle. Okay, so this is the angle to x is going to be our distance dot y atan to distance dot x, and then I take this and subtract. Okay, so let our real angle is going to be angle to x minus self dot angle. Yeah. Oh, just keep in mind that 8tan2 returns it in radians. Do I need to convert? Yes, I probably do. So then I need to convert this to degrees. And then I have this self dot angle. So then we can say self dot angle to checkpoint is equal to angle. So if I do that, so let's take a debug state pod as a angle. So now I want angle to checkpoint, angle to checkpoint. Let's see if that works. Let's see. Scott, hello. How are you doing today? And Goku, hello. How are you? Oh, I wish this was bigger. I wish I can like... Oh, I can do that. Perfect. It is always 0. Well, that's not great. So the angle is never changing away from 0. So that's not... That did not work. Wait a second. I never called it, did I? I need to call calculate angle to checkpoint to have it work. Okay, so in pod, we have init and we have run. Oh, I don't have to calculate the current checkpoint. I actually know what this is. So I can just say the next checkpoint is a point. I have that. Don't need to do that thing. Let's self dot calculate angle to checkpoint, hand it checkpoint. Oh, you need to be mutable now. Okay. You didn't get a morning stream or friend was hammering away on boring stuff? Our friend was hammering away on boring stuff? Oh, are you talking about Toggle? Toggle was doing some work, right? Okay, so I actually run this now. That should help. Ooh, it didn't like that. Cannot borrow data in a... Okay. Okay, so that happens in, oh, we have this init turn. That has that mute self. Wait a second. Okay, so pod, I have init. When do you run? Pub function run, okay. This is in, wait, pod? Oh, wait, does this? Oh, there it is, okay. So, oh, as ref, I do have an as ref. Okay, so I need an as ref mute. I almost wonder if I want like an update. Ooh, Anathema got pushed to GitHub. Oh, it's coming along. So I figure out the checkpoint. I want to calculate the angle to the checkpoint. I figure out what the target is and I go with that. So I kind of want to have an update here. And this will have a mute itself. And the checkpoints. I'm not going to return anything. We're going to grab that, put you in here. You don't need to be mute. We don't need to do that. Okay. Then in library, we're just going to say, let's update here. So let's add an update to state. Right. I don't want to update you. I want to go into the option and mutate it. How do I want to do this? I don't want to unwrap you. I want to probably like if let sum pod equals self dot pod one. Except I need you to be mutable. So can I do something like that? Oh, I can. Okay. So then we're going to do pod dot update. And because I'm lazy, just do 2 lines like that. Okay, so now I can call update. Like that. So I update the data. So we initialize the turn, we update the data, and then we go there. Okay. Okay, so now we have numbers. Okay. Let's turn on debug mode again so we can look at which one's 1 and which one's 2. All right, so we're going to start with this one over here is 1, and we're pointed directly at it. Our angle to checkpoint is 97. Okay, that doesn't seem great. Okay, but after the first tick, we're okay. So it's negative 0.1 and negative 0.3. Okay, so not bad. We're like less than 1. Now, this is 2, and we're going here, so this is a little bit bigger angle, so 2 is 60 degrees, okay? That seems pretty good. Now, 2 is pointing a lot closer to, that's 40. 1 is pointing up here, which is negative 342. That doesn't seem right. That's not correct. It should be... like, even if it's negative because it's to its left, that should be less than like 45 degrees. So this is not calculating it right. Did I get it backwards? I may have gotten it backwards. So maybe our angle is actually self-lit angle minus angle to x. Just need some modding, so then I can clamp it once I get there. So let's try that. Let's also try clamp negative 180.0 to 180.0. Clamp is not right. 370 is the same as 10, not the same as 180. Oh, wait. How do I know what that is? Yeah, you're right. That's definitely not right. Yeah, so 360 is full turn, so it's right back to the front. So 350 is the same as negative 10. When it's pointing directly at it, that's still 0, right? Like, is this correct? Self-lit angle minus or did I screw this up and I don't actually need to delete you? Like, maybe I want to go back to this. Modulo helps, but not always. How would modulo help here? And then I don't want to clamp you. I want to go back to this. Oh, if I angular modulo 360 minus 180, should get it within that range. So the reason that would work is because it can go up to 360 right now. So hold on. So our pod 1 and let's wait until, okay, so 2 is pointed to the right of 2. So that's negative 287. So if that was negative 287 What's a good math library that I can use for this? Can I actually do that in here? Like that, modulo 360. No, wait, I did ampersand? That's not right. That doesn't work either. What's a good math like website that can handle this type of stuff? Oh, Wolfram Alpha. Wolfram Alpha. Okay, so I want that. Modulo 360. So that gives me negative. Okay, so then minus 180. Huh. Oh, it wants, okay. Oh, okay. That's much more making sense. Okay, so then if this is negative 287, this is 72. And looking at that, that looks like it could be 72 to here. Pod 1 is pointing pretty much directly at it. That is this 359, which is 360, so pointing pretty much directly at it. So you are zero point 0.3. Okay, I like that. Yeah, it interpreted the percent as percentage, which I did not want. Look at the input interpretation. It puts the parens in the wrong place. Oh, yeah, that's wrong. I want... How do I get it to mod? Wait a second, what? It didn't care about the... I don't know what the right symbols are for that. Angle plus 180 mod 360. Is that just to get it to work, but I don't really need to do that in reality? Oh, that's weird. Like, why do we need a plus 180 that? The plus 180 is to offset the 180 we take away in the end. Then why do we need to take away the 180? Like, wouldn't it just make sense just do that then? Because then that gives me the same thing here. Oh, mod 360 gets it in a range of 0 through 360. So if this was something like 110, that gives me 249 as the angle. But if I want it between 180 Okay. So then if I subtract 180 from this, it does it the wrong place. So I need to add I need to add 180 here. I guess like I don't really yeah, there's no difference, but I don't really understand this. I mean, so that does give me like way too large of a number. What if I just mod it? If I mod by 180, would that work too? Oh, then 181, which is technically behind me, would be 1. Okay, so I don't want that. So I need the mod 360. And so that means anything close to the 360. So basically anything close to the 360 is like 0, 36, 359, that gets like close to 0 and it stays there. Hero Dev, hello, welcome, thank you for the raid. How was your stream today? What are you working on? And welcome raiders, awesome to have you here. We are working on a coding game. We're playing a pod racing game. And so it's our pods versus other people's pods. We're writing this all in Rust. And currently, I'm trying to find the angle between my direction and the checkpoint that I'm currently going after. And so it's math that I've never really been good at, or at least never been good at understanding and fully grokking. So that's what chat's been trying to help me with. So I guess this number, no, I did not want to do that. If I just mod 360, the higher number it is, the more behind it is for me. But it's still going to be, close to in front of me. So, okay, so if I do angle mod 360, like that. Skimas, hello. We're gonna find out. We may have something a lot closer to reality, and we may not. 180 is directly behind. Above that starts getting closer again, but on the other side. I see things. Did I see something above 360? No, I see 359. So that didn't seem to do what I wanted to do. Okay, so here we are. We have this long straightaway. So both pods are pretty much going after 1 at this point and pretty straight on it. And they're both at zeros. So that makes sense. And as soon as they pass this, now it's pretty far to their left. So we see, okay, 79 and 43, so that feels correct. But here we passed this one, and now we're going over here, and so it is pretty far. So we have pod 1 is negative 126, and that's 83. Okay, so that actually looks right. I think there was one where it was like in the 360s though, right? So pod 1, wait, so what happened here? Okay, so we hit 3. We're going to 4. Okay. So your pod 1 is going pretty much straight towards 4. And so that's negative 0. Pod 2 is going straight to 4, and it's negative 359. So that's incorrect. Rasmus Go, hello. You find it easier to do the math with vectors instead of angles? I guess like the problem is that I have an angle. I guess like the problem that I'm running into is that they give me an angle but that I'm facing relative to east. And then I have the angle between here, and I'm trying to find the angle based upon that. Yeah, it's not incorrect if you turn almost a full turn, you're going directly at it again. Kubalayam, hello. How are you doing today? You've been fighting with Rust for over an hour. Did not realize that it's important borrow thing now. Now I know what you meant in ECS tutorials. Oh, okay, good. That's good. That's learning. We calculated a vector before we left, didn't we? Yeah, so we calculated the vector. So we have this vector. So we have the vector from here. Yeah, so we have this vector right here. And then we're using arctan 2 to get the angle. So here's what I've got. Let's look at the code. So here my distance is the angle between, or is the vector between the checkpoint and my positioning. So I'm just basically taking my checkpoint and my position, subtracting that to get an XY point of that. I then am getting an angle to the X, which is starting with the Y and then doing arctan 2 and going to X, and then converting that to degrees. And then I'm subtracting that from the angle to east. I don't want direction, I want angle. Yeah, I could try the angle plus 180 mod 360 minus 180. I don't really understand that, unfortunately. So maybe I'll have to go around it and tweak it out a little bit. So this is the angle plus. Okay, so we get that angle. So let's do this again here. So let's shadow the angle, and we'll do this new angle plus 180 and then we'll mod 360 and then we'll subtract 180, and then this will be the angle. What are you upset about? Angle equals. Okay. Doing tan stuff is very expensive. It's probably okay with this because I don't have very many checkpoints. I'm only calculating once, and I have 100 milliseconds between each tick to go after, so I don't really care about expensive stuff. I'm still getting negative 360 things. So I don't think that worked. Okay, so for example, let's see. We hit 1, and so now we're both coming after here. So pod 1 is kind of sort of facing towards it. That's 73, and the other pod is 122. So that sounds right. Now we're both pointing pretty close to it. That's fine. Pod 1 is pacing completely away, negative 170. That sounds appropriate. Now pod 2 is facing away from it, negative 180, okay. Negative 198, okay, so it did a right-hand turn, and so it's got negative like 215. So as it's getting, yeah, and the other one is now negative, okay, 359, but it's not pointed towards it at all. It's pointed perpendicular to it. So I don't think that math of the it didn't do it right. You also have the orientation vector from rotating into 1, 0 vector. Well, did we do the rotation, or is that what the arctan 2 is doing? The angle between the distance vector and the orientation vector is cosine h, and then the dot product range oriented magnitude distance. You can also skip the cosine h from the formula entirely and just use the dot product magnitude as proxy for the angle. Oh, it turns out in Rust, oh, I need to get, okay, so you're saying I probably need just the absolute value of this angle before I do this. Something like that. We can try that. Not the absolute value. I think you just need to use if statements if it's greater than 180 or less than 180. And I modulus by negative if it's greater than. I'm not seeing anything greater than 180 now, though. Every once in a while I see a 0, but for the most part, they're mostly positive, which is okay. I don't really care if it's a left turn or a right turn. All I need to know is the amount that's different. Like here, I slam in, so like, so 2 is 81. Okay, that's appropriate. One is 170. Okay, so I think this is right. 150, 112, 93. Okay, so left turn, it's doing correct. One is so okay, 2 is negative 179. Yeah, I don't care about the sign. Okay, so then a right turn, so 1. That still becomes like a negative number. Okay, so I think that's working as expected. So then just to angle the checkpoint, let's absolute value this one last time. And then that should be trustworthy for this. Make a normalized vector for your direction and another for the target, and take the a cosine of their dot product. So a normalized vector for your direction. Which I don't, well, let's see. Do I have my normalized vector? By direction, are you talking about my facing or my actual, like, where I'm heading? Because I want facing, and they give that to me, but only in a single scalar. Take the sine and cosine of the angle to get a normalized vector. Oh, the orientation vector that we were calculating is normalized direction. Okay. But I think this works. Like this, if this gives me what I'm going for, then I don't think it matters any other way of doing it, right? Like this gives that to me. And then what I can do is when I'm running, if I want to slow down, so here's my, I need to figure out what my speed is. So let my speed, so if self dot angle to checkpoint is like greater than, let's say 75. So if it's greater than 75, I want to slow down. So let's multiply 100 by select self dot speed. 100.0 times, what is, actually we can just calculate this. What is 100 times 0.85? Oh, 85, of course. Brain. Okay, so we'll just say we'll go 85. Otherwise, go 100. And you go speed. So go towards the target and go the speed. Either go slow or go fast. So if I do that, so I won't lose speed, won't go faster. I am bumping into myself a lot, which is not helpful. I probably should take that into consideration, but I might actually still just win a bunch of races if I'm not worried about it. I am able to make tighter turns now, though, so that's good. I am in second place in this map, so I'm not beating the boss. We could also do something where like we have different strategies. I'm actually curious though. So we're rank 2,600. Let me see if I can. Yes, I can. All right, let's see how we do racing against you. We should be orange again. Wait, why did that not do the thing? Oh. Oh, that wasn't a good bounce. Okay, yeah. If you're within a certain number of me or like somewhere in the in gold, then I can choose to race against you. So I'm not. Ooh, wait, I'm slightly behind you. No, I got way far behind you. Too many collisions. I wonder if we can do something with shields instead. See how smooth that last tight turn was? Wait, all my turns have now been pretty smooth. So let's see, which one? There's that last turn between like 2 to go to 3. That was... Or are you talking about yours? Like you hit this 5? Yeah, that's a pretty good turn. I could slow down a little bit more, but right now I don't have a good avoidance for anything. We can try... Here, let's try Skimmis. Let's try going after... All right, first of all, am I friends with you? Here, I'll follow you, so that way I can find you again. And let's try a match too. Oh, this is gonna be a rough one for bumps. Oh, did I win? I think I only won. Let's see. So you got to lap 3 first. And then here my pod number 1 is also getting to lap 3. I get bumped and then counter bumped by myself, which helps a lot. So I'm a full checkpoint behind you. And then you're trying to turn back into the checkpoint. You bump me. Wait, were you not on lap 3? You were on lap 3. What happened there? Oh. So you're coming into the checkpoint like that, and then something happened, and you aimed for 1 again. But you're really on this one. And then at this point, your code realized, oh no, I'm actually going to here. And so it did an emergency turnaround and came back in. But by that time, it was too late. You would have won by a full half lap against me. Oh, it tries to go to the next checkpoint a little early. It was so close. So you were probably like a couple pixels. You had like a magic pixel or two that like 601 or something like that. But your code thought, oh, okay, I'm close enough. Let's just go. And if the orientation was different, you would have won. So I bet that if we play another race on a different map, I would lose. Because I think you're faster than me. Yeah, you're 188th and I'm 2000th. Oh, and I'm not using any boosts. I haven't started any boosts yet. Razmago, is it possible to join a race? I think so. What's your username in coding game? And I can add you in and see if you're in Gold League and you're within a certain amount of me, or if you're in a top X, then I can apparently add you in. Yeah, so I'm pretty much losing by at least half a lap. I mean, I got to position 3. Oh, you just signed up? Okay, yeah. So the way it works, which is really unfortunate, is I can add in other people. But only in the same league that I'm in. So I'm in Gold League, so I can only add in people from Gold up to 999. So only the top 1,000 in Gold League. I am currently 2,688, so nobody can add me to play against me sort of offline. Now, actually, let's test. So let's just take my code and just throw it into the arena and see how it does. Because I'm actually curious. Maybe I'll get above 1,000 now. Yeah, you haven't implemented attack and defense yet at all. One of my pods is only focusing on constantly attacking your pods. It's not racing at all. Oh, interesting. Okay. Yeah, that makes a lot of sense. I'm actually getting in my... Oh, look at that. They just... Oh, they're always going to 0-0. Okay, that's cool. So I'm just by racing better and faster, I'm going to get much higher in rank. Probably not enough to beat the boss, I would guess. But like if I get ahead of them in the map, I'm probably going to win a lot more. And then, yeah, you're right. We're going to need to implement some kind of defenses. I probably want to like have one pod offensively going after like another pod. Here, we can take away the debug. The attacking strat seems to be working pretty well. I think my pods are slightly more efficient at turning, but you still beat me easily because my pods get wrecked. Oh, are you talking about like against Skimus? Are you? Yeah, Moomy, you didn't seem to be doing any attacking or defending, so that makes sense. So if you're good at turning and racing and attack and defense, you'll probably get out of gold. That's my guess. Okay, I got a notification. Ooh, I got to 1,541. So we moved up 1,000 points, 1,000 places. So that's good. It's around 4:30, so we need to figure out what plan for next time is. So I need to. Okay, so we've done this. We've slowed down if the angle is too big. So we need to. I don't think I need to experiment with the angle if we're really big. So instead, we need to choose when to boost. So choose when to boost. And then I need to attack, defend. Probably have one pod focused on racing and one pod focused on attacking. I guess here. One pod attacks. And then racing pod uses shields. Defensively. Something like that. And so that will potentially get me a little bit further. As soon as you saw the promotion message, 2 pods now, it was like, it's time to go to war. Yeah. That could be a lot of fun to sort of figure out how we're going to do attacks. We saw one where one pod just went to the finish line and just hung out there and like tried to prevent anybody else from getting into it except themselves. That could be fun too. All right, so we are getting, let's see. So what did we do today? We are slowing down when angle to next to checkpoint is high. Go ahead and push that. And this angle or this code, if you want to take a look at it, here is a link to that code. And if you want to play, it's at codingame.com. So I will be back tomorrow afternoon, and we'll be playing more of this. We're doing this in the afternoons, and in the morning I've been working on a X Twitter clone. So sort of like, more businessy in the morning and then more fun in the afternoon. So we only get to do this for about a couple hours each stream, which is unfortunate, but it's the way that it's the time that I have right now. In the new year, hopefully that's going to change, and I'll be able to redo my stream schedule, and things will be different. It'll be different in a good way, I hope. So might as well also get, if you want to take a look at more vector math approach and the attack code. I probably won't, because I guess I don't count chatting on here as part of sort of figuring it out, but I do like a big thing for me is the fun of figuring it out, and just sort of trying different things and experimenting. I don't actually, it's less important to me of how good I do, and more fun of figuring out as a problem. Does that make sense? That's sort of my mentality for it. All right, cool. So I don't have anything else. With that, yeah, I will keep that in mind though. Thank you for that, Skimus. Maybe it'll be better for when I need to on stream, we can take a look at it too. I probably won't look at it off stream. So that being said, thank you, everybody, for hanging out today. As I mentioned, I'll be back tomorrow morning at 7 a.m. Mountain Time for more Rust programming. So I hope that you have a great rest of your Tuesday, and I will see you all next time. Oh, that did not load. Wait, why didn't my little exit thing load? Oh, because I muted it. There it goes. All right, there you go. Thank you, everybody. Have a great rest of your day, and see you next time. Bye.